In this video, we are going to learn how to graph rational functions. So we've already learned about wholes, x and y intercepts, as well as asymptotes, and we're going to need those. So let's start off with vertical asymptotes and horizontal asymptotes. That's going to help us figure out where our curves will go. So remember, for the vertical asymptote, we look at the denominator, which in this case is x minus 2. And all I need to know is what makes this equal 0, because we can't divide by 0. So I know that if I plug a 2 in, that will make this equal 0. So that is where my vertical asymptote is. I have a vertical asymptote at x equals 2. So I'm going to graph that. I have a vertical line dashed at 2. For the horizontal asymptote, remember, we need to compare the exponents. In this case, we have x to the 1 over x to the 1, or just x over x. Because we have the same exponent, we're going to use the coefficients. And it will be a fraction of the coefficients. The coefficients are hiding just like the exponents. We have 1x over 1x. So that means for the horizontal asymptote, we're going to have y equals 1 over 1, which is just y equals 1. So that is where my horizontal asymptote is going to go, at y equals 1. Okay, automatically we have a much better idea of where our curves might go. So let's talk about x and y-intercepts. Let's do the y-intercept first, since it's a little bit more easy. Remember, for a y-intercept, we make x equals 0 in our equation. So I'm going to plug in 0 into x plus 1 over x minus 2. I have 0 plus 1 over 0 minus 2, or negative 1/2. So that means I have a coordinate at 0, negative 1/2. That is the y-intercept, which is great information because at 0, negative 1/2, I already know where one of my curves is going to go. Next, let's see if we can find an x-intercept. Okay, x-intercept. Remember, that's where y equals 0, or you make the whole equation equal 0 and then you solve. I'm going to multiply both sides by x minus 2, get rid of the denominator. Okay, now I have x plus 1 equals 0. So subtract 1 over, I get x equals negative 1. Great information. At negative 1, 0, I have another coordinate. So now I can plot that as well. Negative 1, 0. That is enough to go ahead and make a curve. Remember, it does not cross the asymptote. It's a wall. It's just going to get really close to it. Now, that does mean our other curve has to be in here somewhere, but we can't just draw it. We need to get more points. I'm going to go ahead and use 4, and let's go ahead and use 5 as well. So I'm going to plug in x equals 4 to get another coordinate. Okay, my equation is x plus 1 over x minus 2. So when I plug 4 in, I'll have 4 plus 1 over 4 minus 2, or 5 divided by 2, which is 2.5. Okay, so we have 4, 2.5. I'm going to plot that as well for 2.5 right there. Let's go ahead and do another one. Let's do x equals 5. Let's just plug in. I'm just picking numbers that I know will end up over here. There's no other reason to pick 4 and 5. I just wanted to pick them because they were over there. Okay, so 5 plus 1 over 5 minus 2 gives us 6 over 3, or 2. So we have another point to plot. 5, 2. 5, 2. That's enough to complete the curve. And we're done. That's how it works. Let's do another one. Okay. The first thing I'm going to do is see that this is factored, which is great, and we can even reduce it. I have x plus 2 over x plus 2. Okay, so I have 3x plus 12 over x minus 3. And I can even factor this top bit more, so I'm going to go ahead and factor out the 3, and now I'm left with x plus 4 over x minus 3. So now we have a reduced function, which will be a little bit easier to work with. Remember that because we have things canceling out, that means we have a hole in this graph. Otherwise, let's go ahead and find the asymptotes. Vertical asymptote. Remember, we just look at the denominator. 3 is what would make this equal 0, so x equals 3 is our vertical asymptote. We'll graph that. Okay, horizontal asymptote. The same thing is happening as before. My x's have the same exponent, which is 1. However, this time the coefficients are not 1 and 1. We have, I'm going to rewrite the equation here, 3 times x plus 4 over x minus 3. We have 3 over 1. So the horizontal asymptote is y equals 3 over 1, or y equals 3. So go to y equals 3, graph a line. All right, let's go ahead and find the hole. We already know the x value of the hole. It shows up in our canceled out terms. -2 would make that equal 0. To find the y value, we're going to plug it into our reduced function. So I've got 3x plus 4 over x minus 3. I'll plop in the -2. So -2 plus 4 over -2 minus 3. There we go. Okay. So 3 times 2 over -5, which is 6 over -5, or -6/5. Okay, so I'm going to draw a hole in the graph at -2 and -1 1/5, or -6/5. So about right there. But remember, make it really obvious. Draw a hole in the graph. All right, let's go ahead and find the y-intercept by making x equals 0. All right, the equation is 3 times 0 plus 4 over 0 minus 3. So 3 times 4 over -3. 12 divided by -3, which is -4. So we have 0, -4 as another coordinate. So let's plot a point there, 0, -4. All right, that is 2 points in one of the quadrants. Let's go ahead and find the other coordinates. Okay, so if I were to find the x-intercepts, that's usually what we would do next. I have 3 times x plus 4 over x minus 3. I would set this equal to 0. Okay, alrighty. So I'd multiply both sides by x minus 3. It's going to cancel out. I'm left with 3 times x plus 4 equals 0. If I divide it by 3 on both sides, I have x plus 4 equals 0, because 0 divided by 3 is 0. Then I subtract 4 from both sides, so I get -4. So we have an x-intercept at -4, 0, which I almost drew correctly, but there we go. We just have 3 points on this side. Okay, but we do not have any points over here, and we know we should have some. So I'm going to go ahead and just plug in a couple of numbers. Let's see, how about 6 and 7? X equals 6. I'm going to plug that in. 3 times 6 plus 4 over 6 minus 3. So that would be 3 times 10 divided by 3. All right, so that's 10. Okay, so 6 comma 10, it's a little bit off. It would be up here somewhere. Okay, when x equals 7, let's plug it in. 7 plus 4 over 7 minus 3 becomes 3 times 11 over 4, or 33 divided by 4. Let's see. So that'll be 8 point something. I'm going to leave it as 33 over 4. So 7, comma, a little bit more than 8. So over here. It's a little bit off our grid, but you get the picture. So it's a long process of finding points, but that is how you do it. Thank you.